Hello and welcome to my video, lesson 8.4, Understanding Sinusoidal Equations, or Sine Functions. So first of all, if you haven't yet, make sure you've watched 8.2 or 8.3, where we've looked at some of these, and especially 8.2, because the sinusoidal parent function is this right here. It's given by y equals sine of x. And we looked at that function in 8.2. But now what we're going to say is we can have a general equation where a, b, c, and d are all rational numbers, so fractions or just numbers or integers. And so what they will allow us to do is to be able to draw the graph or understand the sine function by just looking at those numbers directly. And basically what's happening here is that these four numbers are transformations of the parent function. So it's just the same as when we did it for logarithmic functions, and we had the parent function when we do it for exponential functions, and we have the parent function, or where we do it for polynomials and we have a parent function. It's the same process here. So first of all, what's going on? Well, we're replacing x, right, from the parent function. We're replacing x with bx plus c. We're also replacing, it may not seem quite as clear, but we're also replacing y in this original function with y minus d over a. Is that right? Yes, because then a goes first. So we're replacing it with this. So it may not be quite as obvious, but if we think about it in this way, we can remember that b and c relate to our x value, a and d relate to our y value. So what do each of these do? Well, we're going to see it right below. But let's just talk about it for a second before we even get there. So because c is related to our x and it's adding, that means it's going to be a translation. So c gives us a translation horizontally. Okay, b, because it's multiplying by x, gives us a stretch horizontally, because it's x. Okay, and if we look at our, y values, or our y letters, the ones that are relating to y, so that would be a and d. Okay, a is giving us, because it's multiplying or dividing, let's say, by y, it's a stretch, but it's vertically. D is because adding or subtracting, in the case may be, it is a translation, but it's vertical. Okay, so 2 relate to the x, to the horizontal, 2 relate to the y, vertical, and so that might be one way of remembering this, and I hope that this helps you remember it. But here are kind of the, I'm going to call them formulas, but they're not really formulas, the things that relate to each other. So if you take a look here at amplitude is a. Okay, so if we look at the sine function as we talked about in the last two topics, the sine function, the amplitude is given by a from our general equation. Okay, the period is given by 2 pi over b. So again, looking at our general equation, a, b. The phase shift is given by the value of c, so negative value of c. Keeping in mind that we just need to know if there is a phase shift or not. So if c is 0, if it's not there, there is no phase shift at all. Okay, and the midline is given by d. So d just gives us straight up the midline. So you write y equals d. I don't want you just writing d. Y equals d. It's a midline. That is key. All right, and if we're looking for our max and minimum values, that would be given by d plus a would be our maximum, and d minus a. Well, why is that? Well, again, d is our midline, right? Plus our a, our amplitude. So it isn't just some random thing. It's because we have a midline, and when we have these functions, we have a midline, and we want to know the distance from here to here, well, that would be our amplitude, right? And then same thing, it would be for the minimum, is the distance from here to here, well, it's subtracting by that same amount. So again, midline, but now it's subtracting the amplitude. All right, so with all that in mind, maybe I can zoom out a little bit. Go ahead and try this question out for yourself. Here we have an equation. I want you to fill in the values. So pause the video, try it out for yourself, and see if you get the same answer that I do. All right, so I'm going to try this out now. Maybe zoom in just a tad so that you can see what I'm doing. So amplitude is a. So where's the a value? So that's right here. So amplitude is 3. The period is 2 pi over b. So let's take a look here. 2 pi over b. Well, b is the 2 here. So maybe let's write this out. 2 pi over b, and b is 2. So this would equal, just canceling out the 2's, so it'd just be pi. Would be the new period. Is there a phase shift? Yes or no? Well, let's look at our equation. We have a c value. Yes, we do. It is 1, so it'd be a -1 phase shift. It'd shift to the left. All right, and we have a midline of -4, so we'd write y equals -4. Okay, so what else can we do? Well, we can get the max and min by writing d plus a, which again is the midline, d plus a, which is the amplitude, and the minimum would be d minus a, so the -4 minus 3, so -7, and here we'd have -1. So our maximum is -1, our minimum is -7. Now if we were to write that in a range, we would write it like this. And x is in the real numbers, as it always is for sine functions. So just an aside here for half a second. I remember which direction is bigger because of this actual size of the opening being bigger than this tiny little tip here. This tip is very, very small, not very big, so that number also has to be small. So like 2, and on this side we have 100, right? So that's how I remember which side's bigger. So what this is saying here for our range is that y is bigger than -1 or equal to -1, and it is less than -7 or equal to -7. All right, so I hope this video helps you understand sine functions and how to kind of manipulate them and understand them a little bit better. Good luck.